Okay, here are a couple more alternating series test examples. This is on page 29, the 3 problems at the bottom. These are slightly different than some of your standard ones. Okay, cosine of n pi. When you look at this series, it doesn't look like it is an alternating series. I don't see a -1 to the n anywhere, but think about what happens. When I plug in 1 for n, you get cosine of pi, which is really your first term in the series is -1. If I plug in 2 for n, your next number, notice you get cosine of 2 pi, which is 1. So your next term in my series is +1, and then it just rotates 3 pi, 4 pi, etc. So notice it is an alternating series. It just alternates from -1 to 1. Okay, this can be rewritten as this. So n equals 1 to infinity. The series starts at 1. So you can rewrite it like this. So now if you see it written in this form, it is an alternating series. So you can use the alternating series test on this if you want, but the easier way to do this is notice that this is a geometric because your r is really -1 here, so with the absolute value is not less than 1. So the easiest way to do this problem is show me that it's a geometric, r is -1 and it diverges. Okay, so using number 7, look at 8 now. So you see that cosine of n pi on the top? So I'm going to rewrite this series as -1 to the n, which takes care of the cosine of n pi, and then 1 over n is still there. So this is your alternating series. Okay, I know the numbers are going to alternate, so I'm going to check my two conditions. Is it true that the limit of the general term without the -1 piece, does that go to 0? Yes, this limit is true. Is it true that for every value of n, that the n plus first term is always less than the nth term? Yes, this is also true, so I can say it converges by AST. Okay, let's try this one, number 9. Again, I can see right away that it is an alternating series, so I'm going to use my alternating series test. So, first thing I check, is it true that the general term is equal to, the limit of the general term is equal to 0? Yes, infinity's on the bottom, this limit is 0. Is it true that if I plug in n plus 1 for n, be careful, if you plug in n plus 1 for n, it's got to go in quantity parentheses, so it's really 2n plus 2. So I'm going to go ahead and multiply that out. Is that always less than this? Yes, that is a true statement. The number on the bottom is bigger, so the entire fraction is smaller. So this also converges by AST.